All right, here's some review help with your Chapter 5B review. And this starts with synthetic and long division. Synthetic division is one of those things I think students get pretty well, but long division is typically a problem for a lot of students. So I'm just going to kind of try to break it down pretty in the simplest way that I know how. And that is, if you look at these tips, and you could feel free to pause it and rewind and things like that. I don't think we call it rewind anymore, but scroll back, whatever you call it. But you want to break long division down into three simple steps. Because step one is after writing it in long division form, which we know what that looks like, hopefully. You want to decide what multiplies by the first term outside to get the first term inside. All right, and then you put that number back into the correct column. All right, so there's distinct columns when you do long division. Step two is to multiply back. Take the number that's on top, multiply it back times the divisor, the number that you're dividing into, the other number, and put the numbers in. Put the numbers in the correct column based upon what their degree would be. Okay, what the exponent of the x term would be. And then lastly, subtract down, and you'll get another number, and then you're going to start the process at the beginning. And I'll show you what that looks like with this particular question. Here's one where you can't do synthetic division. A lot of students are like, can't I just do synthetic, please? Can't I just do synthetic? And this one you cannot, because x squared plus 2 is what you're dividing, and you can't break that down. It's not. There's no number that you're going to put out in front with synthetic. So in this particular case, I'm going to write it like this. And the trick here is, just like with synthetic, it's a good idea to hold the places of the exponents that are not there. So in this case, 5x to the fourth, 0x to the third, negative 3x to the second, 0x, and 4. Okay, and so that's the first step. That's long division form. Okay, and that's the first step I'm going to do. So now step one says what multiplies times the first number here to get that number. So the answer to that is 5x to the second. If that's hard for you, 5x to the second times x to the second gives me 5x to the fourth. If that's difficult, take some time and think about it, and make sure you know how to do that. And the next thing I do is I put it in the correct column. A lot of times students will make the mistake of putting 5x to the second right here. Okay, that's not the x to the second column. Be very careful as far as where you put this. X to the second is right here. So that's 5x to the second column. That's where you want to put it. All right, so that's step one. Step two is to multiply back. 5x to the second, and when I say that, I'll multiply this times this and that. Okay, I'm going to erase those lines, but basically what I do is I distribute that number 5x to the second times the two numbers that I just see there. So 5x to the second times x to the second gives me 5x to the fourth. And there's your check. If that comes out to this first number, you did it right. You found the right number. 5x to the second times 2 is 10x to the second. You got to be careful. Again, 10x to the second has to go in this column. So once again, clearly defined columns have to be taken into account. So let me erase those lines so you can see what's going on here. So at this point, you're on to step three. Step three is to subtract down. This subtracts down, cancels. 0x to the third minus nothing is 0x to the third. Now it gets a little tricky. Negative 3x squared minus 10x is negative 13x squared. Okay, and I bring down the other two terms that are to the right. Okay, so there's your trick. When you subtract a positive, you just make it, minus 10. If it was a negative, it would be minus minus. We're going to hopefully see that in a second. So anyways, that's my three steps. Now it starts all over, and I say, okay, well, multiplies times x to the second to get 13x to the second. Well, that's negative 13x to the second. Well, that'd be negative 13. Okay, so now I multiply back. Negative 13 times x to the second is negative 13x to the second. Negative 13 times 2 is negative 26. And now I got that. Now I subtract down. So these cancel. Negative 13 times minus 13 gives me plus 13. And I got 4 minus 26 gives me 30. And now I try to start the process over and say, what times x squared gives me 30, but nothing does. So at this point, I'm pretty much done. I just have to write the remainder over the divisor, which is x squared plus 2. So my final answer, 5x squared minus 13 plus 30 over x squared plus 2. Okay? So that's a long division. That's hopefully break it down to those three easy steps, and you'll have more success with long division in the future. The next question I want to do is factor completely. When you factor polynomial, you want your answer to look like this, okay? F of x equals something times something times something. All right, so you have to understand what the answer is going to look like, because there's other questions that ask you to find the zeros, and they look basically the same. So the process involved here is you're going to find a zero, okay? You're going to find one or two zeros based upon the equation. In this case, I only need one zero. Once I do synthetic division one time, I'm going to get that x to the third down, divided by 1x, and you'll get x to the second. So I know that I'm going to only need 1 0. So how do you find it? Well, you go to your calculator, okay? That's the way we're going to learn how to do it here. So I go to my y equals, I type the equation in. Be careful to make sure it's in there correctly. Okay, 2x to the third minus 3x squared. See, I already messed up. Okay, so 3x squared minus 8x minus 3. All right, at this point, I just want 1 0. So I kind of just look at my table, and I find out the x values where y is 0. The zeros of a function are the x values for which y is 0, and I see 1 right there. I don't need to go any further. I could use the 0, so I found x equals 3 from my calc. Okay? So what that means to me is that the number x minus 3 would be a factor, because if x equals 3, positive 3 is a 0. So if positive 3 is a 0, I'm going to have x minus 3 as a factor. Once again, I need to know what my answer looks like. I already got one of 3 factors. So at this point, I do synthetic division. I don't have any missing terms. I got x to the third, x to the second, x, and my constant. So I just do synthetic. So this comes down. And here's the process. 3 times 2 makes 6. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 8 plus 9 is 1. 3 times 1 is 3. And here's your key. If that remainder is 0, you know you did it right. So now that's my remainder. Here's my constant. Here's my x, and here's my x squared. So this is my new equation. All I'm left to do now is to factor that, okay? So at this point, I take 2x squared plus 3x plus 1, and I factor it, and I do MAF or whatever I need to do. So 2x squared plus 3x plus 1. Change colors, go MAF. M is 2, A is 3. 1 multiplies the 2, but adds the 3 is simply just 2 and 1. My lead coefficient is something other than 1, though, so I have to take that into account when I do my MAF. So x plus 1, x plus 2. Lead coefficient of 2, divide each of these by 2. That doesn't reduce, so I'm going to call that 2x plus 1. This is going to give me x plus 1, because 2 divided by 2 does reduce. So my final two factors are 2x plus 1 and x plus 1. Okay? So this is my answer. I didn't want to find the zeros. Not really interested in the zeros. I'm interested in the factors. So I found the first factor with my calculator, and then I found the other two factors by doing synthetic and getting a quadratic, and then factoring the quadratic using MAF. So that was number 5. Number 9, on the other hand, it says find all the real zeros. And in this case, you know that you're going to find the zeros. And I'm going to start with my calculator. But once again, I decide, do I need 1 0 or 2 zeros? In this problem, I need 2 zeros. Okay, I need to do synthetic 2 times because I have x to the 4th. If I do synthetic 1 time, my new equation will be x to the 3rd. And if I do it 2 times, then it'll be down to x to the 2nd. That's something that I can work with. So in this particular problem, again, I'm going to go to my calc. I'm going to type it in. Again, make sure that you're typing it in correctly. And because most of the time, students are like, I don't see the zeros. Most of the time, the problem is just you just type something in wrong. Okay? So don't freak out if you don't see any zeros. You probably just messed something up. Just look at your equation, take your time, and type it in. So I already think I messed up something, right? I see that negative 38x right there. Okay, what that's going to do, that little mistake right here, is going to take and multiply instead of subtract. So, I mean, just kind of look back at your equation, make sure everything is the way you want it. Okay, so I got negative 38x, negative 13x. All right. And I already see another mistake. So I got x to the 4th, and I didn't add a plus in there. So, I mean, little things like that are going to mess you up, and you're going to get, it'll still graph it for you. That's the funny thing. Is you're like, oh, yeah, it graphed it, but it's all messed up. So this looks good. And now I'm going to look at my table again. I'm going to try to find some zeros. So I see 1 0 at 4. and I see other zeros at -1, -2. So actually, when you do this in your calculator, a lot of times you're going to see a lot more zeros than you really should see, because we do want you to do synthetic division. So I'm going to take two of them. I'm going to call them zeros from calc. And we're going to use like x equals, how about -1 and 4? Okay, you can pick whatever ones you like. I'm going to use -1 and 4. Okay, so when I look at my answer, again, since it's an x to the 4 equation, I know I'm probably going to have 4 zeros. Okay, whether they be real or imaginary, I'm going to have 4 of them. And I know that my answer is just going to be x equals this, 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 and this. These are my zeros. Okay, it's not like the last one where I ask you for the factors. So just be careful about what the answer is going to look like. All right, so the zeros from my calc, I got -1 and 4. So I'm going to take, and I'm going to go ahead and do synthetic with -1. Much like the last problem, there's no missing exponents, so I can just write the coefficients straight across. So I'm just going to do synthetic. -1 comes down, -1 multiply 1, -1, -14, 14. It's going to give me -24, 24. And you know you did it right because your remainder is 0. From here, I'm just going to jump right in with my other 0, and I'm going to add straight down. So I bring down the 1, 4, I get 5. 4 times 5 is 20. -14 plus 20 is 6. And I'm going through this fast, but synthetic is a pretty easy process once you've done it a bunch of times. So at this point, you see, like, I got my remainder, my constant, my x, and my x squared. So this corresponds to a new equation, x squared plus 5x plus 6. And I'm trying to find the last two zeros. So I'm going to set that last part equal to 0 and see what I can do. And this is just a pretty easy MAF. M is 6, A is 5, F is 1 and 6. No, not right. 1 plus 6 is not 5, it's 7. So the answer is, what multiplies to 6? Well, 1 and 6, but in this case it's going to be 2 and 3, because 2 times 3 makes 6 and 2 plus 3 makes 5. So there's my answer. There's nothing in front of the x squared, so it's just x plus 2, x plus 3. At this point, I do want to keep going. That is the factored version, but I want to find the zeros, so it's -2 and -3. And like we saw, if I go back to the calculator, you see the 0 at -2. So that shouldn't be a surprise, but I do want to see the work that gets it there. So it's -2 and -3. And those are my last two zeros. I get 4 zeros, and I should have gotten 4 because my degree was 4. That's your indication of pretty much how many zeros you're going to have. And I know I needed to do synthetic twice because my degree was 4 as well. All right. Number 14 is a polynomial function that has the given zeros. And you're like 6 and 3i. And what you got to know, the tips here says write the zeros as a product of factors. We'll talk about what that means and show you what that looks like. With I, though, there must be two factors, because if I is a 0, then -I is a 0. And that's your trick there. Okay, I is the square root. The square root of anything has plus or minus. So since I is the square root of -1, I know automatically that -3i is also a 0. And the next question I'm going to ask, I'm going to do this question two different ways, but the next question I'm going to kind of answer is, if 3i and -3i are two zeros, what did I set equal to 0 to get that? And because I can kind of think backwards and I have the ability to get there, I can see that one of my factors, if I set this equal to 0, I'm going to get plus or minus 3i. All right, and if you're like, I don't get it, what are you talking about? Well, if I subtract 9, I get -9. If I square root -9, I get plus or minus. Square root of a negative is I, square root of 9 is 3, plus or minus 3i. So I could see that x squared plus 9 would be a factor. If you can't see that, just go ahead and go through the process. But I'm going to do both ways and show you how that works. But if 6 is a 0, x minus 6 is a factor. If these are both zeros, x squared plus 9 is a factor. If you don't see that, you could do it this way too. If 6, 3i and -3i, you could say x minus 6, x minus 3i, and x plus 3i, and you could FOIL that all out, and that takes a little bit more time. I'm going to do both ways. But again, point being, if you could recognize that if these are zeros, that's a factor, that's going to help you out, and that's kind of what I just showed a second ago. So I'm going to multiply now to get my result. So for the first one, it's pretty straightforward. It's a pretty easy FOIL question. First, outer, inner, last. I get x to the third plus 9x minus 6x squared minus 54. I'm going to put it in the correct order. And that would be a polynomial function that has the given zeros. If you want to make it like y equals, that's fine. But y equals x to the third minus 6x squared plus 9x plus 54. And I should say minus 54. I messed that up. But that would be a polynomial function with the given zeros of 6, 3i, and negative 3i. Right? Again, if you didn't see what we were saying here, I'm going to give myself a little bit more space. Then you got to FOIL out the x plus 3i and minus 3i, and you got to remember your rules with I. Okay, the rules with I say if I multiply I times itself, I get I squared. I squared is negative 1. So in this particular problem, I got x minus 6. I'm going to leave that alone. Okay, but what you're going to eventually see is by FOILing this out, you're going to get x squared minus 9, or x squared plus 9. So this gives me x squared first, outer 3i and negative 3i cancel, and then my last negative 9i squared. Okay, so these are going to cancel out. Negative 9i squared is negative 9 times negative 1. Negative 9 times negative 1. Negative 9 times negative 1 is positive 9. Okay, so what you see is even if you start there, you're going to end up at the same spot. So you see like x minus 6 times x squared plus 9 is going to be where you end up either way. All right, when you FOIL that out, I mean, I could do it all again, but it's the exact same thing. You're going to get x to the third minus 6x squared plus 9x minus 54. All right, and I hope that helps you with your Chapter 5b review.